Hi everybody. My name is Nick Davidenko, and I'm here to tell you about my research lab. And I'm we have some time at the end for questions, but you're also welcome to raise your hand or put a question in the chat during the presentation if you have any questions that come up. Um, so here's one big splashy intro slide to my lab, which is called the High Level Perception Lab. So what high level perception means is I'm interested in perceptual processes that go beyond kind of the early stages of encoding, like in visual, auditory, tactile perception. There's kind of a hierarchy of processing from the early sensory information, like in vision, what's going on at the level of the eye's retina, all the way up to higher areas of the brain that are interested in understanding meaning and context, and how that sensory information kind of interacts with everything else going on in the environment. So I'm interested in those high level processes, and that encompasses a pretty wide range of research topics. Um, I've been at UC Santa Cruz for 13, 14 years now. And when I came in, my main area of research was face perception. And I've been interested in that question for a long time, kind of from the point of view of what makes faces so easy to remember. And for most people, we're humans tend to be really good face recognizers, although it does vary a lot across the population. But in general, we're very good at that. And I've been interested for a long time about what aspects of faces that we pay attention to, how we encode that information, and how we are able to sort of learn a face or kind of recognize a face and then be able to recognize it in other contexts, in other formats, in changes of expression, changes in age, all sorts of things that can modify a face, and we are still able to recognize it. So I'm interested in those questions, and I've done some work using mathematical modeling and computational modeling to kind of capture the some measures of the range of variability across faces and see how some of those factors affect people's ability to remember them. So that's one piece. That's kind of where I got my start in research. Um, then once I got to UC Santa Cruz, I started investigating a different phenomenon, which has to do with perception of motion. So for this one, it's actually useful to do a little bit of a demo. So I'm going to ask you, all of you who are watching, to look at that big square in the center of the screen that has lots of pixels, and raise your hand if at any point you are seeing the motion that I'm saying out loud. Okay? So you can raise your Zoom hand if it happens that you start seeing motion consistent with the words I'm going to say. Okay? Here we go. Up, down, 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 up, down. Oh, sorry. Are things not moving? I just got a message that it might not have advanced to the next slide. Is that right?
Yeah, it looks like you're still on the first one.
Oh, okay.
There we go. Now it's moved.
Sorry about that. I'm going to leave it in just this format instead of full screen, just in case. Um, so let's not start over. You can look at this morphing face on the left. That was what I was kind of referring to earlier. In the way that we study faces is to try to capture what faces are and how they vary. Um, but the second example, has to do with this thing. Um, I'm going to try to zoom in on it a little bit because it works better when it's, oops. Can you all see that now? Okay, so let me try this again. Okay, here we go. Up, down, up, down, up, down, up, down, up, down, up, down, up, down. Raise your hand if you saw motion that kind of went up, down as I was saying it. Excellent. So I see about 10, 12 hands up. Okay, now I'm going to say different words. So you can put your hands down, and I'm going to do a different one now. And again, raise it if you start seeing the motion that I'm saying. Left, right, left, right, left, right, left, right, left, right, left, right, left, right. Okay, awesome. I'm seeing um, about 13, 14 hands now. So who thinks they know whether the motion is really moving up or down or left, right? They can't both be right, right? Well, it's actually neither, right? So what you're seeing is completely random pixels. These stimuli are created in MATLAB, which is a programming language, and basically what you're seeing is just one random pixel array after another. There's no coherence, nothing is really moving. But we discovered that people are really susceptible to perceiving coherent motion in in stimuli like these where there's a lot of randomness. If there's enough randomness in the stimulus, it seems to allow the mind to just interpret things in a variety of ways. And one of the ways is by priming. So like what I was just doing, saying up and down or left or right. But in our lab, we do it a little bit more subtly, and we have actual motion as a type of priming. So we show people pixels that are actually moving up and down or moving left and right, and we get them to see that real motion. And then we introduce these completely random pixels and see whether that real motion is continued to be perceived. So we've done lots of work on this type of phenomenon in the past 10 years or so. And I can tell you a little bit more about it if people have questions. Um, so I'll move a little more quickly through the last couple of things. Another area of my research in my lab has to do with sensory integration. So in the case of this motion and the faces, this is, these are stimuli in the visual modality, but there are lots of processes where auditory information interacts with visual information, and also other types of sensory information can interact, like vestibular information. So in this drawing of this person kind of lying on a chair facing up, this is one of the manipulations we do in my lab is we put people in different orientations and present them with different types of visual tasks. And the questions underlying that are, how does your body orientation and how does your sense of gravity affect how you perceive the world? And how does your perception of the world differ if you're upright versus if you're lying or tilted in different positions? And then another big area of my work has to do with audio-visual mapping and mental imagery. So I'm going to talk about it in a little bit, but there's a condition called misophonia, which some of you may have heard of before. It has to do with um, uh, being having an extreme aversion to to specific types of sounds that often include chewing sounds or sniffing or other mouth-related noises that people make that can cause people with misophonia to feel kind of a sudden surge of anger and kind of a feeling of wanting to leave the room. So we're actually investigating the non-auditory aspects of that condition. So besides the fact that there are certain sounds that can be triggers in misophonia, we've shown in our work that visual information can modify how people interpret sounds, and even things like mental imagery. So the thinking about potential different sources of a sound can can change the way people react to those potentially triggering sounds. So that's a really broad, big overview of a lot of my different research areas. So in the next 8 or so slides, I go in a little bit more detail about some of these and tell you about some of the results we found. But before I move on, I wanted to just um, pause for a minute and let you take this in. And if you have questions, I'd love to answer them. Oh, actually, I have a question for the organizers. I had a student ask if this could be recorded. Would that be possible?
Yeah, it's actively being recorded. And
Oh,
then
perfect.
once we're done with the presentation, it'll eventually be uploaded to YouTube, and then you can find the link. I'll post the link where you could find the video in the chat for everyone.
Okay, perfect. Thank you. So no questions. Um, if you do, feel free to put it in the chat or raise your hand. I'm happy to pause to make sure everybody is following. Okay, so I'll move on. This is the most recent lab photo from my lab, but this doesn't reflect the whole lab. There's many people missing from this photo, but we took this at the end of last quarter. In this picture, I have Golnush, who is a PhD student, Gazelle, who is a postdoc. She recently graduated with her PhD last year from my lab and is staying on as a postdoc. Um, Everyone else here is an undergrad research assistant, including Amaya, who is currently one of my lab managers as well. Um, but we typically have about 10 to 15 undergrad RAs in the lab helping in different ways. I'm going to tell you later about the different things that RAs do and how people kind of get involved in my lab. But so I already um, kind of d did this demo with the motion perception, but I wanted to kind of put it a little bit in more context. So what you're seeing here is called an apparent motion quartet. And this was kind of discovered in the um, 80s as a easy way to produce an ambiguous percept. And this is kind of the basis of a lot of the work I do is when something is ambiguous, that's where the mind can kind of choose to interpret things in different ways and can be primed to interpret things in different ways. So how is this ambiguous? Well, you probably many of you are perceiving it as two like red dots that are moving up and down. That's like the most common way that people perceive this, but it's also equally possible that you perceive the two balls as moving left and right. So there's like one ball at the top that's moving left and right, and another ball in the bottom that's moving left and right. So if you use your hand to just kind of cover up one of the balls, you can kind of perceive them in going in different directions, or you can just kind of like tell yourself to see them in some direction, and it will happen at some point. So you have control over how you interpret ambiguous visual information. And so I just kind of wanted to refer you back to this image. Um, we did a lot of studies using this and seeing how many people could sort of perceive coherent motion in this. And we ended up publishing a paper in the Journal of Vision with three undergrad research assistants at the time who were really helpful in helping me um, collect data from participants, pilot the experiments, and give feedback and even help in the writing process of the paper. I also mentioned that I'm interested in vestibular ways in which the vestibular system interacts with the visual system. So this is kind of a cartoon of one of my studies uh, where we have people essentially try to perceive information like faces or words in different orientations. So we know from a lot of research that face perception, specific, for example, is very sensitive to orientation. So if if you look at a face like this, if I orient it upright, it's very easy to see the face and the expression that it's making. But if I take the image and make it upside down, it becomes much harder to see to understand the expression. And if we put it sideways, it's sort of an intermediate level of performance. So that's been known for a while that faces are very sensitive to orientation. But what my studies looked at is whether that depends on the way that the participant is oriented to. And we've done studies with face recognition as well as with a lexical decision task. So in the lexical decision task, there are words and non-words that are presented at different orientations, and people have to determine which, if any given string of letters is a word or not a word. And what we've shown across several studies of this type is that when people are tilted, they sort of maintain some preference for upright stimuli in the environment. That means that even if I'm tilted as an observer, I still kind of do better at perceiving words that are upright or um, a little bit tilted the way that I'm tilted, but not the ones that are fully tilted the way that I'm tilted. In other words, people develop sort of a reference frame that is some sort of average between their own reference frame, the way that they're tilted, and the kind of gravitational reference frame that says up is where, gravity tells you up is. So people kind of develop a compromise reference frame that is kind of tilted in the environment. So we've used simple studies in this where people just lie down and look at a screen. We've also used VR, and VR allows us to much more carefully capture the orientation of a person's head and also be able to present stimuli at different orientations with a lot of control over that. Um, and then I wanted to just say a few more things about our work on misophonia. So, like I was saying, misophonia is a relatively recently described condition. It's only been around as a term for about 20 years, but it actually turns out to be fairly prevalent. And what we have been showing in our research is that if we can modify the way that a person interprets a sound, it can really affect how they feel emotionally about that sound. So in this image, I thought this was going to be a video, but it looks like it's just an image. Basically, you see a video of somebody tearing a piece of paper, slowly, so you hear the tearing sound as the video goes on. And when you watch it, it looks like just somebody tearing a piece of paper. But in reality, the sound that you're hearing is somebody crunching on chips. So every time the paper tears, you hear one bite or one chew. Um, but it's done so carefully that it really looks like the sound is coming from the tearing paper. So what we've done in our studies is we've had people come to the lab and listen to sounds, listen to some triggering sounds, some non-triggering sounds, some under the original visual context and some under these modified visual contexts. And what we've shown is that the visual context really matters. So somebody who might have a very immediate negative emotional and physical reaction to hearing somebody chewing would have a much more subdued response if they think that the sound is coming from this other source, even if it's the same exact sound that typically triggers them. So I do have a bit of a video of one of the ways we run these experiments in my lab. And so what you're going to see here is the point of view of a participant um, who's watching um, who's watching a set of videos, and as different sounds come up, they're instructed to either pay attention to the image or to the video on the left or the video on the right, which is kind of provides different sources for that sound. You're not going to hear any sounds as I play this, but you're going to see this little hot spot. That's where participants' eyes are. So this is data from an eye tracking study, and this little red dot that's going to be moving around shows you where that participant was looking at any given time. Here they're answering questions about how pleasant that sound was. And here they're being asked to basically keep their eyes at the center. That participant is not cooperating very well because they're moving their eyes around. I think that was probably just me, just making a demo for the video. But in any case, you can see how the eye tracking data can help us confirm if a participant is paying attention and looking at the right source. And then, we use a lot of behavioral measures like how pleasant or unpleasant did you find the sound? Did it make you feel any sensations in your body? Um, Things like that. But we're also using some more implicit and physiologically based measures. So we have the ability to measure pupil changes in with our eye tracker. So not just seeing where people are looking, but how much their pupils are dilating or contracting. And we also measure galvanic skin response, which is a measure of um, basically electrical activity that happens in your skin as you sweat, and different triggering events can lead to more sweating or less sweating. And so we have a way of measuring sort of physiological responses to these potentially triggering sounds. And then for my last research topic that I want to talk about, I already said a few things about this type of work. We're interested in understanding how faces vary and how those variations affect memory. But I'm also interested in understanding how people look at faces. And so we've done some eye tracking studies and found that when people look at tilted faces like this one, they tend to focus on the eye that's higher up. And we call this the upper eye bias. Um, we don't know yet why, but it's a very prevalent bias that people have. Like it maybe shows up in about 96% of people, and only 4% of people prefer to look at the lower eye. And that's whether we tilt the face to the left or to the right. And we're currently doing some follow-up research trying to understand why that happens and if it happens with just with faces or if it happens with other kinds of objects that have, a similar geometric structure where we could measure that. Okay, so that's another fairly quick overview of some of my specific research projects. And in my last slide, I have some notes about what sort of involvement in my lab looks like, how people usually get get in touch with me for these opportunities, and what RAs do. But I'm also happy to pause again for a second if anyone has any questions.
I actually have a question
Yeah,
about the misophonia. What are like the most common, if there are any, like trigger sounds for people who have misophonia, would you say?
that's a great question, and we do pretty much know. So there's been enough studies published now showing kind of like very similar results. Um, Chewing is the most number one most common trigger, um, but related sounds like smacking lips, slurping, um, um, like toothbrushing, they're also common triggers. There's also kind of breathing related triggers that are very, very common, like sniffing, um, swishing, like swishing water. Um, and there's a kind of a debate in the field about whether other sounds that are not like what they call orofacial sounds would count as misophonia because a lot of people also report being triggered by like finger tapping, like somebody going like this, um, or it can or pen clicking or just typing kind of loudly on a keyboard. And some researchers think, well, those are a little bit different. Like when it comes from the body, it's like one type of trigger or like true misophonia. And when it's from environmental sounds, it's maybe something different. I don't know where I stand on that. I'm not sure if it matters to make a distinction between those, but those fall out as kind of the most common categories. And there's a lot of really interesting parallels that people experience in misophonia too. It's not just that they converge on the same types of trigger sounds, but they also seem to develop misophonia around the same age, around age 12, plus or minus a couple years. It's usually almost always starts with a family member that like chews loudly at the dinner table, or it could be like a sibling or a parent. And then over adolescence, it can either sort of get better or it can get worse. And if it gets worse, then it can stick around for a long time and then eventually sort of extend to other people uh, being triggers as well as like other sounds.
And then kind of in the same realm, like, do you know like what the treatment, if there is any for misophonia?
So that's another really good question. There isn't any established treatment for misophonia. What people do and have sort of been converging on is adapting treatments for other conditions that have some overlap with misophonia, like OCD, for example, and do therapies that are modeled after OCD, but more centered on the misophonia triggers. Some of it has to do with sort of looking deep into sort of like the relationships with the people who are often seen as triggers. One thing I know is that um, certain things don't work as therapy for misophonia, like exposure therapy. Even though exposure therapy can be really helpful for like phobias and for PTSD, it tends not to be effective for misophonia. And the reasoning there is that if it were effective, then people would would get over it because the triggers are everywhere, right? So people do get plenty of exposure and it doesn't seem to relieve their reactions. So some of the work we're doing with imagination is actually geared, like aimed toward interventions for misophonia. The idea that in the moment, even in the presence of a triggering sound, people might be able to sort of redirect their attention in a way and re kind of like play with the interpretation of that sound. Like just think of different ways of interpreting those sounds as not as threatening or not as harmful. Um, and so we're in the middle of that type of investigation. Are there any other questions?
I think there's a few questions in the chat.
Oh, sorry, I did not see those. Thanks. Let's see. Um, okay, let me start at the top. So could this have something to do with the upper eye being more central to the face? Yeah, that's a really good question. Yes. Yeah, and sort of like the way that faces geometry is, there's very little we can do to really dissociate those two things. We can try other kinds of objects that are not faces. So see the difference between like the upper dot in some object versus the most central dot in some object to tease those apart. But that's a really good point. The only thing I will say is that we do find that, if it were just a matter of centrality, then sometimes a lower dot is equally central as an upper dot, and we don't see a preference for the lower dot in those cases. So I think there is something about the upper visual field. Um, so another question is, do you have interest or have done work in aphantasia or anendophagia? Um, I am interested in aphantasia. So for those who don't know, that's has to do with um, people's inability to conjure vivid mental imagery. So a lot of people can kind of close their eyes and picture things in their head to some degree, both visual and auditory or other sensory experiences. But some people don't have a vivid access to that. And for visual mental imagery, that's called aphantasia. There's an auditory version that's called anauralia. So that's if you can't sort of imagine sounds or speech or music in your head. I have not heard of anendophagia, so if somebody wants to tell me what that is, I can respond, but I hadn't heard that word before.
It's just like not having like inner speech, not being able to hear your own voice in your head.
Yes, so I guess I was kind of hinting at that with it's like maybe one type of aneroilia, but yeah, I find all those phenomena really interesting. I haven't done much research myself on that, but we do we do sometimes administer the VVIQ, which is like a test of visual imagery vividness, and we do sometimes make predictions for some of our studies based on whether somebody is um, kind of high or low on that scale. So, okay, the next question was, are there lab opportunities for recently graduated students? That's tough. It can sometimes happen in the summer, um, because there might be projects that need work in the summer, and a lot of the normal like current, enrolled research assistants are out for break. But during the school year, preferences are given to enrolled students who can, use those opportunities for course credit. So, but it does happen that somebody who has been in the lab um, stays involved in the lab after they graduate. That is quite common. Um, I see. And the next question is about the upper eye bias, and if it is influenced by luminance distribution, by lighting conditions, and that is a good question, and it probably is, but we haven't tested that. So the way we've looked at that question is um, either we're with these kind of schematic faces that don't have shading or lighting information, or with photographs that we just rotate. Um, so no matter where the lighting is on the original photograph, the rotation sort of maintains the lighting into whatever that part of the face was. So we don't think that it's caused by like lighting coming from above or from any one given direction, but it's a good question. Okay. Another question. For beginning research assistants, what tasks should we expect to start with or learn first, such as eye tracking or misophonia studies? So, the first and most important task that research assistants do are is to run participants. So when an RA first joins the lab, they complete some like required online trainings. They learn sort of like the mechanics of the lab, where we keep consent forms, how we do things. There's the online trainings, by the way, have to do with just best practices for dealing with human subjects participation and data, things about confidentiality and um, consent and what's required for those things. Um, but once they're trained, and they're trained usually by one of the graduate students or a more senior research assistants, the main task is to be in the lab when participants come in. And the way my lab is organized is that everyone learns how to run all the studies that we're running in any given quarter. So a lot of labs work differently where RAs are more kind of, assigned to one specific grad student or one specific project, and then they work on that, whatever that project needs. So my lab is kind of split a little bit into just general uh, participant running duties that are kind of throughout the week and scheduled around RA's own schedules. And in addition to that, contributions to a specific project. And that kind of grows over time as the RA spends more time in the lab. So they can come in kind of open to multiple projects, and then over time they become more involved in one, go to those group meetings, contribute by, different things like reading papers, summarizing, entering or coding data, or whatever the project might need. Does that answer your question? Okay, I have another question here. With misophonia, are the reactions just anger-based, or do other strong emotional reactions happen like panic attacks? Great question. So panic attacks can happen too. So it's not just anger. Anger is sort of like the most reported emotion, but anger, frustration, um, and then physiological signs of flight or fight. So like increased heartbeat, increased sweat, tension in the body, and a desire to leave the situation. Sometimes the anger becomes, directed toward a person. So there's also kind of desires or fantasies of lashing out at the person. Although it kind of rarely happens, but it's in there. But that's also not the only set of emotions. It can also include disgust, um, as well as like other kind of like social attributions to the person producing the trigger sounds. Okay, and then the last question I see here is, I'm interested in aphantasia and endophagia, uh, getting involved in labs that might do that. Well, yeah. So I think my lab is one of the labs there that might be interested in that. Um, I mean, the anandaphasia thing, the your own mind's kind of monologue, that might be intersecting with some interests with other faculty like um, Liv Hoverston or Megan Bodwin, who study language processing. Um, Maybe also might intersect with the work of Jamal Williams, who's interested in also multisensory cognition and mental imagery as well. But there's opportunities. So if you have like a particular research interest, there can be opportunities to do an independent research project. So usually, when you join the lab, there are already ongoing projects. And as an undergrad, the first job is to sort of become, proficient at running studies and then become more and more familiar and contributing to one of the projects. But, you know, every once in a while, I would say once every couple of years, I have, or maybe a little more frequent than that, I have a student who comes in with like a very strong interest to conduct an independent study. Sometimes, and so this can be a senior thesis, or it can be just an independent study, as long as the study makes sense, is worth doing in terms of like feasibility for being successful and being publishable. So I have had examples of those projects taking off. So I'm going to quickly go to the next slide because I just included this one extra slide where I listed just the last several papers that have come out of my lab, and all of the names that are highlighted are undergrads. Um, these are, peer-reviewed publications, and just to show you that um, undergrad research assistants really can become deeply involved in the research to the point of being co-authors or even first authors on publications. So um, G. Mullen, that Gray Mullen, he was a cog sci major who graduated in 2020 or 2021. And he came up with the idea for this project. I basically served as his supervisor, and we worked on some of the writing and the design together. But he had an idea about how virtual reality might warp people's sense of time. He designed the study, he implemented it, we ran it, and he ended up being first author on the paper. So, yeah, those are kind of, the range of possibilities. A lot of times, research assistants join the lab, they help run participants, and that's, they contribute to a project, but they don't have necessarily an interest in going deeper, and that's fine as well. Um, I've I don't, so going back to my previous slide, I don't really ever post ads for RA positions because I'm always, I always get contacted by interested RAs, and with way more people contacting me than I can bring in, even if they're qualified and they're on solid academic standing. I just can't, there's just not enough room or enough things for people to do. So I have to kind of limit it to a certain number of people. And so when it comes time to make choices, then people who are, really more intrinsically interested in research and potentially pursuing a research oriented career are given some priority. Um, I take seniors, but I do usually require a two quarter commitment. So by spring of your senior year is probably too late. Although there have been exceptions where I've had somebody in the lab for a quarter or maybe stay over the summer. If like the interest and the match is like really, really strong, then it can happen from time to time. But usually the best recipe for success is to start early. So to start maybe sophomore or junior year in a lab, and then that amount of time, if you stay in the lab, is what can let you sort of become an independent researcher and be able to do your own work, if that's what you're kind of most interested in. Okay, so I see and there's another question about one of our studies, the emotion recognition study. Um, I think that is one that so we're looking at how people perceive emotions in naturalistic stimuli. So a lot of the studies on emotion perception are done with photographs of faces, and in this study, we're looking at short video clips because in real life, people don't make expressions in the sort of canonical or standard way that you think. So somebody smiling in real life or showing an angry expression, it might just be a tiny little movement or like a kind of change in the pose of your head or a way in which the eyes kind of tense up. And so we're looking at whether people and specifically we're interested in autistic traits among the neurotypical population and if um, those kind of predict different strategies that people use to detect emotion in naturalistic faces. So without giving too much away, that's sort of what that study is about. I got another question about programming experience, and I did mention I think that programming is a uh, plus if you have some of that experience. And the question was specifically about our programming. Um, we tend to use a lot of MATLAB in my lab. That's just because that's the language I know and I'm familiar with, and it's very useful for running a lot of the studies we do. But any programming language that you come in with can be an asset. So if you know a programming language and you feel comfortable enough to kind of develop an analysis script or develop like a new experiment idea, that can be really useful. And it can be like a really good skill to build if you're interested in eventually pursuing a PhD in research.
All right, I have one more question to end this off on. I was wondering what advice you would give students interested in grad school or research careers.
Um, so if you're interested in a PhD program, PhD programs are very, very specific. What will get you accepted into a PhD program has more to do with the particular lab that you're applying to work in than sort of like your general application. Um, Before you apply to a PhD, you should take a significant amount of time to read and learn about what different labs research is about. So before you apply to a lab, read several of the papers from that lab and become very familiar with that work. And the admission into that lab is going to depend on how well you are able to describe your interests and your sort of background in a way that matches with what that lab's program of research is about. You can be a straight A student and have like excellent scores and have, experience, but if you don't have a very directed, statement of purpose that describes where you show that you know what this research is going on in this lab and like you show why and you make a convincing case that you want to pursue that work, it's very hard to get in because it's really, really competitive. Usually, um, faculty advisors can only admit one graduate student in a given year or none. And so you are potentially competing with a lot of other applicants just to get into that one lab, and you have to try to stand out by showing that you really understand what is the work they're doing and why you want to pursue that. I would say that's the number one thing. If you're thinking about a master's program, that's very different, and you don't have to be that specific. And then it really does matter more about, like having a good GPA and having a good number of prep courses that you've taken and having, you know, just a generally strong application, but you don't have to be as specific because the point of a master's program is to train you in more research methodologies, and you usually end up rotating different labs. With a PhD, you're really just going to work with one PI, one professor. So it's important that you understand that and that you make a good case for why that makes sense.
All right. Does anyone else have any other questions? Or Professor Davidenko, do you have anything else you'd like to say?
I just saw one more question about PsyD. Uh, so a PsyD is a doctorate for clinical psychology. Um, I think that it's a little bit different in terms of like, I made the point for PhD, you really want to like center it around the research program. It's a little bit different because PsyDs are more clinically focused. So maybe then it's more about what kind of clinician you want to be trained to become, not so much about which specific professor, although that might be a factor. So I wouldn't be the necessarily the best person to tell you about the PsyD process. I'm mostly expert in the PhD side of things. So thank you for all your questions. And I put my email out there, so you're welcome to get in touch if you have any follow-up questions. Happy to chat with you.